This tutorial is for 3rd grade, Module 3, Lesson 9. In this lesson, we're going to use kind of a chunking procedure to help us multiply greater numbers. The first problem is 3 times 12, and you can see the array that's been drawn as 3 rows of 12 triangles. It would be rather difficult to come up with the final answer on that because some students have a hard time skip counting by 12. So if you look below that, they've chunked those triangles into smaller groups. The reason we can do this is we can think of 12 as 3 times 4. We're going to take the 3, and we're going to show that we've taken this array and we've chunked it into smaller arrays that are 3 rows of 3. And that's what the picture down below is showing. I know that 3 rows of 3 is the same thing as 9. So each of these groups has 9 triangles, and I have 4 groups. 9 times 4 is 36. That tells me then that 3 times 12 is also 36. So I rewrote the 12 as 3 times 4, and I chunked some arrays that were 3 by 3 arrays in order to solve the problem of 9 times 4 and get 36 for our final answer. Let's look at another problem. This one is 3 times 14, and we started with 3 rows of 14, but we're going to break that 14 apart. I'm going to break it into 2 times 7. And that allows us to chunk the big array into smaller arrays. And if I group them, you can see that we now have arrays that are 3 by 2, 3 rows of 2. And again, we get that 2 when we break the 14 apart into 2 times 7. These groups show the groups that have been rewritten down below. In each group there are 6 circles because 3 times 2 is 6. I have 7 groups. 6 times 7 is 42. That tells me that 3 times 14 is also 42. Basically, the goal again is to chunk the array into smaller arrays that can help us figure out the total number of dots without having to count every single row. We're going to use a similar procedure in the next section, only this time we're not going to use the pictures. Here, the first problem is 3 times 12, and we're going to rewrite the 12 as 3 times 4. Now, that will allow me to change my parentheses. That's called the associative property when we keep the numbers in the same order, but we group them differently. Instead of taking 3 times 12, I'm now shifting my parentheses around the 3 times 3, and that means I'm doing 9 times 4. 9 times 4 is 36, which means 3 times 12 is also 36. The example over here is 3 times 14. 14 is the same as 2 times 7. I can shift those parentheses then and multiply 3 times 2 to get 6. 6 times 7 is 42. So 3 times 14 is 42. Here are a couple more examples. I have 15 times 3. I'm going to break the 15 times 3 into 5 times 3 times 3. 15 is the same as 5 times 3. That allows me to shift my parentheses. And now the problem I'm doing is 5 times 9. I know that 5 times 9 is 45. So 15 times 3 is also 45. One more example. Here we have 15 times 2. I can rewrite 15 as 5 times 3, and then I'll shift my parentheses, put those around the 3 times 2. That means we're now going to solve the problem of 5 times 6. since 3 times 2 is 6. 5 times 6 is 30, which also means 15 times 2 is 30. So using the associative property helps us break the numbers apart and change the problem into a multiplication problem that we already know. And that helps us multiply these bigger numbers.